Hello students, hope all is well. YouTubers, and because I'll be teaching Organic 1 Lab this summer completely remote, I'm utilizing BeyondLabZ Labs software, virtual organic chemistry. There are modules for general chem, biology, physics. I have not looked at those, but what I'm doing in this installment is showing you, the viewer, how a Grignard would be conducted in the lab. And when students, at least my students, when they go on to Organic 2 Lab, will have a pretty strong mental image of what's involved so they can hit the ground running at that time, hopefully when they can get back in the conventional lab. I will also use this software in a hybrid scenario where before certain labs, or even in lecture, I would utilize this to take a break, let's say, from lecture material and show the students one of these videos. Anyway, let's show you Grignard. Victor Grignard, of course, was the first recipient of the Nobel Prize in Chemistry somewhere around 1902 for his discovery of the reagent that bears his name, a very essential part of synthetic organic chemistry. So we have Grignard selected here, and what I'm going to do is select phenyl magnesium bromide. Double click, it'll go in the round bottom. You can see it on the blackboard. And I'm going to add to that acetone. So let's see if they're there. Okay, let's put in ether solvent, and we have all three components. Let's go to the stir plate. We'll put a heating mantle in, attach a reflux condenser. Don't forget nitrogen gas. Make a note of the time on the clock, 7:27. You can go forward if you want. If you go too fast with certain reactions, the glassware will explode, so you have to be cautious. All right, I'm going to get started. Let's do a TLC. And we can already see a product's forming. Do you see it on the blackboard? There's your the phenoxide portion, or the alkoxy magnesium bromide, which will be hydrolyzed in the workup. So there's still Grignard, there's still acetone, 2-propanone. Let me go ahead now. It's done. Now you only have solvent and the magnesium ionic form of the Grignard. Okay, watch what we do. You can save this to the notebook. For example, if I put save, if I open up the notebook, the TLC will be there, and a student would be asked to put their name, the experiment they're doing, the date, and TLCs and other observations. I'm going to exit out now. I won't keep the notebook, but that's a very, very good feature. Okay, I'm going to X that out. Now what do? We're going to do a workup. So you click on the SEP funnel. And now what do you add? Do you add water? Sodium hydroxide aqueous, HCl aqueous? Well, we had a Grignard. It's on the alkaline side, so we're going to add aqueous HCl. Let's check the layers. Bottom layer, magnesium bromide chloride and water. Sometimes you get gelatinous precipitates, which can be a nightmare. And the top layer we want, now listen carefully, it has diethyl ether solvent and 2-phenyl 2-propanol. I would have my students always look up the physical properties of starting materials and products. This particular target molecule, this alcohol, there's the structure on the blackboard, is a solid. So what we're going to do is put the top layer into the evaporating dish, and that would simulate a rotary evaporation, or putting in a fume hood and letting the volatile ether evaporate. And you can see the solid in there. That's the product. Okay, let's characterize it. So we're going to do a melting point. And the way we do that is to bring this over, click on the melting point apparatus, and you can see the melting point of this substance is about body temperature, 37 degrees. Let's do the FTIR. You can see your OH stretch. your aromatic action, about 1600. In this case, they're showing us for the aromatic ring. There's your aliphatic aromatic carbon-hydrogen stretches, sp2 hybridized carbons in the aromatic ring. Very nice, very, very nice. Now, you can use online the SDBS, Japanese Analytical Society Structural Database, and it's an excellent database, and it will carry infrared, proton NMR, C13 mass spec, even ESR, for quite an impressive library. So you could save this to the notebook, but I'm going to just click OK. Now, let's do the proton NMR. Got to line it up just right. It can be tedious. Not doing it. Not doing it. Let's try C13. Isn't that something? They don't have it, so I would have to have my students looked at SDBS. Let's try the mass spec. Here's the mass spec. I'm going to have to let BeyondLabZ know that they left out proton and C13 NMR. So there, the students would get that from the SDBS. Here's your mass spec. Your molecular ion is healthy, even for an alcohol, which is unusual, but there it is. And at 121.714164. And there's your base peak. That fragment is showing up at 43.095. I'll click OK. And that's what it is. Let's try that C13 one more time. NMR. No, they don't have it. They don't have it. All right, melting point, infrared, mass spec, and that will conclude this little experiment. Bye for now. Now, let me show you the X out procedure. If you have a mistake, if you make a mistake, you just click this for clear the lab, and you're ready for a new experiment of any type. When you're ready to leave, upper left corner, click exit. Then what you do is go up here to exit. I'm not going to save the notebook, so I'll click OK. And then up here for BeyondLabZ, you L-click, at least with my Mac, right there to X out, and you